Hey, welcome back. This is Mr. Kelly. Today we're learning about quadratic functions. We're in lesson 4. I'm going to divide it into 2 parts. We're in part A. This is like a part A. Way to go. We're going to start on page 45. You know what? Here's exactly what we're going to learn. We're going to learn about the general form of a quadratic equation, the factored form, and the vertex form. These are all different ways that a quadratic equation can look. So that's pretty easy. It's just 3 different ways it could look. And then lastly, you know what a parabola is, right? It's the shape of a quadratic equation. It's like a U, right? Well, we're going to learn about this word concavity. What does that mean? It has nothing to do with the dentist. We're going to start on page 46. Look at that. We already moved a page. That's how fast we're moving. It says use the given points to sketch possible solutions. How many lines can you draw through point A? So if you recall, if you just give me 1 point, I can put a lot of different lines through it, right? In fact, I can put an infinite number. How long you got? We can put as many as you want through that 1 point all day long. But when you give me 2 points, A and B, you can only draw 1 line through it. All right, let me try. I'm going to try my best. Hey, turn up. Look at that. So I can put 1 line through points A and B. I can't put any other lines through those 2 points. It's just not possible. No other lines exist. Now, if you give me exactly 3 points, it's not going to work because well, that doesn't work. If I pick any of the 2 points, right? Suppose we have A and C. B is not on that line, right? But suppose I do, let's do B and C. Then A won't be on that line. So if you have 3 distinct points and they don't happen to be on the line together, you can't draw a single line through those points. So what are you supposed to learn from all this? Well, you're supposed to learn that for a line, linear functions, you need 2 points. That's what you need. Just 2 points and you can draw that line. Okay, so now we're going to talk about parabolas. How many parabolas can you draw through a single point? And it's very similar. You can draw, let's see, I'm going to try to freehand this. We'll just confuse myself there. So as we have page 46, it asks us what is the minimum number of points you need to draw a unique line. You need 2 points. But for page 47, that's where we talk about the parabolas. We have an infinite number of parabolas you can draw through a single point. So what if they give us 2 different points, kind of like they did with the line? Remember the line, we could only draw 1 line through those 2 points, but I'm going to try this again. I'm going to try my best here. How many parabolas can we draw? All right, this is pretty good for me, but I've drawn 3 different parabolas in the 3 different colors through those 2 points. A little shaky. Apologize for that, but with 2 points, you can draw an infinite number of parabolas. Check that out. Parabolas are like bendy, right? So we can bend a couple through there in different ways. What do you think this is going for us? All right, through three points, you can only draw 1. There's only 1 way to draw a parabola through here. You can't draw one that's facing up, right? Because that would not include point B. So I can only draw one that's facing down. I'm going to try to do this in real time for you. You can watch the skills, watch them unfold. So I'm kind of like eyeing this up. I think that if we have one like this, and then we can come around this way, there's only 1. See, if you don't make it, just make point A a little bigger. That's all you got to do. Make point A a little bigger. All right, there you go. So there's only 1 parabola you can draw through 3 points. That is part of the lesson. Hey, make sure you're writing this stuff down. So we're going to check your notes. You can only draw 1 parabola through the 3 given points. So what's the moral of the story? Well, linear functions have 1 set of rules. Parabolas have a different set. You need 3 different points to draw a parabola. Well, why is that? We're going to get into that. We're going to talk a little bit about that later. But we're going to look at quadratic functions now before we tie those 2 pieces of information together. Quadratic functions are functions that have an x squared. We already know this, right? They have an x squared. We have 3 different forms of it. We're going to talk about those 3 different forms right now. We're on page 48. We have a general form, which is ax squared plus bx plus c. We've already worked with this. It's when we factor a quadratic function, we always would start with it in general form, and then we would end up with it in factored form. We would have a quadratic equation that had some factors to it. And then lastly, we have a form called vertex form. Not sure if you're aware of that, but I will talk to you about vertex form, and all 3 of them are useful in their own ways, right? Some of them show what the factors are, and you can just look at it. Other ones show what the vertex is. It's not too difficult because it's in the name which one does which. And the general form is very nice because sometimes we want to find like a y-intercept or something. You just plug a number in, and it's so easy to do with the general form. So depending on what you want to do, you can use different forms of this quadratic function. Another idea that we're going to talk about is concavity. Now, this value of if you notice, the very first value of all of these forms of a quadratic function is a. And so if a is positive, we get a parabola that opens up. This happens when a is positive. But if a is negative, we get a quadratic equation that faces down. This is called the concavity. Okay, the concavity is whether it opens up. This is concave up, and this is concave down. The way you need to think about it is it's concave up like a teacup. Look, I just made a teacup. And it's concave down like a frown. That's clever, right? Clever. Let's talk about these three different forms. The first one is the general form, ax squared plus bx plus c. What we can use from this is we can find what's called the axis of symmetry. So every quadratic equation, every parabola has an axis of symmetry. The axis of symmetry is the line that divides it right down the middle. And it's really easy to get the equation of that line. First off, it goes through the vertex. So if we know the vertex, then the x-coordinate will tell us where the line of symmetry is. But if we don't know the vertex, then we can just use this fancy little formula right here, x equals negative b over 2a. You're going to want to write that down because negative b over 2a is a simple, tiny formula. We look at whatever b is, and we divide it by 2 times a, throw a negative, and boom, we got the equation of that line. That's helpful if we need to find the vertex, because then we can take that x value and we can just plug it in the equation. It'll tell us the y value. So a tells us whether the parabola is concave up, if a is positive, or concave down. All right, that's easy enough. And the form of a quadratic function reveals different characteristics. The general form we just talked about, you can determine a y-intercept by just plugging x equals 0 in, and whether it's concave up or down, if it's in general form. That is the first form of a quadratic equation. Now, the next form is called the factored form, and you guessed it. If you take this equation and you factor it, then you will get the factored form of the equation. And the factored form tells us very quickly what the roots are, right? So if you remember, the roots are where the quadratic equation crosses the x-axis. It's where the equation equals 0. So we can tell very quickly the x-intercepts, and we can also determine whether it's concave up or concave down, because it also has that a that's hanging out front there, just like the other equation did. A is leading the pack. So if it's positive, it's concave up. If it's negative, then it's concave down. That is the factored form of an equation. And lastly, we have the vertex form. The vertex form is, look at this, a times x minus h squared plus k, and we have the vertex is hk. Some things to point out that students mess up a lot. It's x minus the h value. So if you know that the vertex is 2, 3, we'll say you have a parabola and the vertex is 2, 3, we would do x minus 2, and then we would square it, and then we'd add a plus 3. That's easy enough. But suppose the vertex is negative 5, 7. Then we could write that as x plus 5, because it would be minus negative 5, right? So instead of writing minus negative 5, we just write plus 5, and then we add the 7 at the end there. So remember that on the inside of the parentheses, the value is always going to be opposite. So if you have a positive 2 for the vertex, it'll be minus 2, and if you have a negative 5, it'll be positive 5. But vertex form, it tells you, I mean, you guessed it, it tells you exactly all about that there vertex real quick, and whether it's concave up or down, it's got that value of a. And you can find the axis of symmetry when it's in vertex form, because you know the vertex, so the axis of symmetry would be just that x-coordinate. Okay, so let's look at some actual problems here. We're talking about problems. Describe the reasoning you use to either eliminate or choose a function. We're now on page 51. Let's do the first example here. Number 1, we're going to look at this parabola, and we're going to determine, could it be any of these? Could it? We're going to look at it and tell. So if you notice, these are all in different forms. They're all quadratics, though. If I were to multiply this factored form out, this is factored form, right? If I were to multiply it out, then I would get a general form equation. And I have to do a little more work to put it into vertex form. But they want you to look at the different forms and tell, is it possible that this parabola right here is each one of these? Now, what we notice about this, it's got two roots and they're both negative, right? Because here's the origin. So I went left. So if I were to find the roots here, the roots had to be negative. Furthermore, the vertex has a negative x coordinate and then it has a positive y coordinate. But it doesn't tell us what the actual numbers are. We just have to go by that. Lastly, notice how it's concave down, kind of like a frown. Well, that means that A is negative. A is negative. We know that because it's concave down. So I'm going to look at all my equations right now. If A is not negative, I'm going to cross it out. So it's not this one. It's not this one. A is negative. Remember, A is the first number that we look at here. And notice how for all of these, A is negative. Woo! Good news. Now, I'm going to look at vertex form because we have these two right here. One vertex, it has to be negative and then positive. And if you remember what I said, whatever's on the inside, the vertex is going to be opposite that. So the vertex of F6 here would be 6, 3. And that would be all the way over here and then up. It would be in quadrant 1. So I know this parabola could not be F6. Where's my other vertex form? Oh, right here. Check this out. We have negative 6, positive 3. All right, so that would be negative positive. It is possible. It's got that negative A at the beginning. So this would be a frowny that goes upside downy. So F8, that is possible. It could be this equation, not sure. Okay, now we're going to go to our factored form. That's F1 and F7. Notice how it's factored for us. And we factor it because that tells us about the roots. The roots. If we set these equal to 0, all right, and then we solve it. Remember, the roots are where the equation equals 0. The y equal to 0 is the x-axis. This is just y equals 0. So where does the function equal 0? The function equals 0 where this equation would equal 0. Will negative 2 ever equal 0? No, I don't need to worry about that. But if I set each one of these factors equal to 0, we'd get x plus 1 equal to 0, and then x plus 4 equals to 0. So I would get x equals negative 1 and x equals negative 4. Based on this parabola, that's possible. Look at that, negative 1 and negative 4. So this could be negative 1, this could be negative 4. It looks pretty good. A is negative. It looks like F1 is possible for this parabola. Let's look at F7. I'm just going to find these roots kind of in my head here because I can do this now. I'm a big boy. I can just do this in my head. X would equal negative 2 or x would equal positive 3. Notice how this root means x equals positive 3. That means that I would have a parabola that's, you have a negative root and a positive root. So it would look something like this. And the y-axis would go down the middle. That's not this one, so I can cross it off. So now we only have one more to check. To check this, I'm going to use my good old formula for the axis of symmetry. X equals negative b over 2a. With this formula, you can find the line that goes down the middle of your parabola. So right here is the axis of symmetry. If you notice, the axis of symmetry is negative in this example, which means that the vertex would be negative. So let's do this. Let's find the axis of symmetry, negative b over 2a. So we look at our equation. B is negative 3. So x would equal negative 3. So be careful with your negatives. It's all over 2 times a. A is negative 1/3. Oh, this is ugly. This is an ugly axis of symmetry. So we get a positive 3 over a negative 2/3. All I need to know is that number. Oh, that's a 3. All I need to know is this number is going to be negative, right? So, I mean, you could do a little math here, and you would get negative 9 over 2. It's an ugly decimal, but all you need to know is it's negative, and this axis of symmetry is negative. It's possible. That tells us that this quadratic equation would be possible. Now, suppose I wanted to find the vertex. Let's take this a step further. I'm going to plug this into the equation. So if you notice what I did here, see this equation that I used to have all nice and like cleaned up? Oh no, where did my calculator go? Get back here. I took this equation, and where x was, I plugged in the x value, negative 9/2. So we have negative 1/3 times negative 9 halves squared minus 3 times negative 9 halves. I plugged it all in and I got 0.75. So I know that the vertex, if I were going to use this, I got 0.75 when I plugged it in. So if y equals this, I'm sorry, if x equals negative 9 halves, then I worked it out and y would equal 0.75, which we'll just say that equals 3/4, just so we stay both with fractions. So I know the vertex would be negative 9 halves, comma 3/4. I could also write it with decimals. Most of you probably would appreciate that. Negative 4.5, comma 0.75. That would be the vertex, right? So it's negative and positive. This parabola is negative and then positive, so that could be the vertex. Wow, look at all that stuff we learned from all the different forms of a parabola. You might have to go back and rewatch that because that was a lot of stuff. So if you need to do that, go ahead, pause the video, rewind it. It's another 3 minutes of your life you'll much appreciate. Okay, the last part of this lesson, we have the 3 different forms we just learned about and all the wonderful stuff. And now we're going to turn to page 53. We're going to identify the form of each function. So I'll do A, and then maybe you can do B. How's that? So for A, the form of this function, this is in factored form. So we'll write that out. It's in factored form. That is the form of the function. And I could tell because I have 2 factors here, right? It's been factored for me. Then, after we identify the form, done, write the function in the other 2 forms, if possible. If it is not possible, explain why. So this is in factored form. What can I learn about all this stuff? Well, I'm going to start looking at this. Let's just graph it. Let's just find out what those roots are. So the roots here, I'm going to write it out here. We have f of x is equal to negative 2. So that tells us it's concave down, right? So I know it looks like this. That's what that negative does. And then it's x plus 1 times x plus 4. So if I were to find the roots, if I set this all equal to 0, where will this equal 0? I don't have to worry about that negative 2, right? So I can just kind of cross that out, and I'll get x equal to negative 1 when you set that equal to 0, and x equal to negative 4. These are the roots. Well, what can we tell about this? So negative 1 and negative 4, that's like over here and over here. That's negative 4, this is negative 1. And I know that it is, concave down. So I know the parabola kind of looks like this. Now, can we find, I'm going to write this out. This is x equals negative 1. X equals negative 1. This is x equals negative 4. So where would the vertex be? Oh man, come on, Mr. Kelly. X equals negative 4. Write that out. The vertex would be in the middle of these, right? So can we find in the middle of negative 4 and negative 1? Like what value is in the middle here? And if you can't, then let's just do a little average here. You just have to average them up. Add them up and divide by 2. This gives you negative 5 over 2, and that's the same as negative 2.5. That'll tell you where the middle of the function is. That makes sense. It's got to be in the middle of these roots, right? Because this is symmetric. So this line right here, the axis of symmetry is negative 2.5. It's in the middle, and it's a decimal, but it's kind of ugly. So we know that the axis of symmetry is negative 2.5. We can plug that in here and try to find the vertex. Oh, that's ugly. Well, let's do it. Here we go. Oh, you know what we're going to do first? Before we do that, let's rewrite this in general form. Let's do a little algebra. We get f of x equals, I'm just rewriting it here, negative 2 times x plus 1 times x plus 4. To write this in general form, I'm going to multiply this all out. We have to do the math, right? Do all the algebra. That negative 2 is going to chill, though, just like Bobby Dylan. So when we multiply x times x, we get x squared. X times 4, we get 4x. And then on the inside, we'll have 1 times x, which is 1x. And then 1 times 4, which is 4. And after, I'm going to put that in parentheses. After I simplify all that, we will get negative 2 times. We'll get the x squared. That chills. These two go together. It's like peanut butter jelly. And then we have that plus 4 at the end. And now I can distribute that negative 2. Be careful of that negative. So we get negative 2x squared minus 10x and then minus 8. So I found the general form right here. We're almost done, peeps. I promise. I had to settle back in my chair here. So negative 2x squared minus 10x minus 8. This is the general form. General form. General. General. general form. Okay, and we already figured out that the axis of symmetry is at negative 2.5. So if I plug a negative 2.5 into the x value, like here and here, then it'll tell me what the y value is, and I'll know the vertex. How fun is that? So let's plug that in. Let's let x equal negative 2.5. So that means I'll have negative 2 times negative 2.5 squared minus 10 times negative 2.5 and then minus 8. I'm plugging the axis of symmetry, the middle of the parabola, into the general form equation. By the way, I could have plugged it into this one too. It doesn't matter which one I plug it into, but I'm going to plug it into here, and it's going to tell me what the y value would be. So y, after I figure this all out, let me get out the calculator. Here it is. I plugged it all in. Look at this. That's a minus, and that's a negative. So if you ever get an error, sometimes it might be that minus and negative, but I'm just plugging in negative 2.5, and I get a positive 4.5. Thank you, Cal. Cal's my trusty calculator. So I know that the vertex here is negative 2.5. This is the vertex. And then 4.5, which is pretty close to what I drew over here. Sometimes when you draw it at first, you're a little bit off, but that's pretty close. We can write one more form. We have, did I write that with an E? What? General form. Is that general? Yeah, that's right. Okay. And then we have the factored form. We have the general form. And now lastly, we're going to do vertex form. Now we know that the A value is negative 2, right? So I'm going to start this. F of x is equal to negative 2. And it's going to be x minus the x value of my vertex. So remember, because our vertex x value is negative, I'm going to write plus in here. We're going to add a squared to it because this is a quadratic equation, and then we throw the value of y at the end there. So this, every vertex is in the form h comma k, and so it's x minus h. So if that's negative, I plug a positive in there. But we're done. What do we have to do? Answer the question. Identify the form of each function, then write the function in two other forms if possible. It's possible. I did it. So we have the vertex form, we have the general form, and we have the factored form. Ta-da! We just did A. Guess what? It's your turn to do part B by yourself. Go ahead and do part B right now. Pause the video, try it by yourself. Okay, so let me tell you what I got here. On page 53, remember. You're supposed to do part B. They give you vertex form, so you have to square the x minus 6. Squaring it, remember, double distribute. This is where students will make a mistake. You'll ignore that. And then I get 2x squared minus 24x plus 77. That's called the general form, right? So does this factor? So I'm trying to factor it out, and I'm going to teach you a little trick here. Let's do tricksies. Remember that I'm trying to factor this, so I need to do a times c, which is 154. Now, I don't know about you, but I don't memorize like the factors of 154. They have to add to negative 24. So what I can do is I can use my calculator here. I'm going to put in that 154. I'm going to hit y equals, and that brings me to this screen. So 154. By the way, if you don't like factoring, you should have a calculator right now doing this. And we're going to divide it by x. This is a little trick. Divide it by x, and when you do that, you can hit second and then go to the table, and we get all these values. All of these values multiply to 154. So I can scroll up and down, and I can look for 2 that might give me a 24. So let me start at 0. I know it has to be negative, so I'm going to go up. These 2 would never give me 124. That cannot give me 124. These are all decimals. This will give me a negative 29, but not negative 24, right? And I'm going to keep scrolling up. 11 and 14, that gives me negative 25, but not negative 24. And if I scroll up, that gives me negative 25 again. I've passed the point where it would be negative 24. You can keep looking in here, but it's not going to be possible. So doing it this way with a calculator, all right, I have tried to find some factors. I can't find any. Now let's actually just look at the graph and find out why, though. I hit y equals. I'm going to go back and clear that out. Let's type this in. 2x squared minus 24x, and then plus 77. All right, I'm going to do a zoom in 6. That's my best window. Check this out. It's up here. It doesn't cross the x-axis. There are no roots. So whenever you have a quadratic equation and it doesn't cross, you can't factor it because it can't factor. It's got no roots. No roots. So that's why I say the function does not cross the x-axis. Therefore, cannot have real number x-intercepts, and I cannot factor this function. This is enough for the first part of the lesson. So you're going to practice this with your practice problems, and then we'll come back and do the second half of the video. Good luck to you all. This is Mr. Kelly in K-Town. Remember, it's nice to be important, but it's more important to be nice. See you.